Welcome to Mathema-Six, the number system. What is the number system? Actually, there are several number systems. You already know the natural numbers, also called the counting numbers, 0, 1, 2, 3, and so forth. We will be working with the rational number system. Rational numbers include the natural numbers plus negative numbers. So 0, 1, 2, 3, and so forth. -1, -2, -3, and so forth. And fractions are also a part of the rational number system. Let's take a look at fractions. In the rational number system, fractions are on the number line sandwiched between their nearest integers. Just like whole numbers, fractions can be negative or positive. To refresh your memory, you multiply fractions across. So 1 over 4 times 3 over 8 equals 1 times 3 over 4 times 8 equals 3 over 32. What does it mean to divide a fraction by a fraction? Let's take a deeper look. You know that when you divide a whole number by another whole number, the quotient is smaller. The whole is equal to 1. The green graphic is our image for 1. And 1 divided by 4 equals 1/4, and 1/4 is less than 1. You can see from the graphic that 1/4 piece is smaller than the whole. Did you know that when you divide a fraction by a whole number, the quotient is also smaller? So here the piece is equal to 3/4, and 3/4 divided by 3 equals 1/4, and 1/4 is less than 3/4. And did you notice that the quotient is 1/4 of the whole, but the piece is 1/3 of the 3/4 piece? It's important to know what your base is, whether you're working with a smaller piece or you're working with the whole. Did you know that when you divide a fraction between 0 and 1 by another fraction between 0 and 1, the quotient is larger? Yes. The idea that dividing a number produces a larger result is counterintuitive. Let's explore the mechanics of dividing by a fraction first. We use the standard division procedure. So term 1 divided by term 2 equals term 1 times 1 over term 2. Assume that term 1 equals 1/4, and assume that term 2 equals 3/4. So 1/4 divided by 3/4 equals 1/4 times 1 over the quantity 3/4, and that's equal to our quotient. So let's multiply each side of the equation by 3/4 and simplify. And then multiply each side of the equation by 4/3 and simplify. So the standard procedure for division applies to fractions as well. For fractions, simply flip the numerator and denominator in term 2. Another way to look at the last problem is that 1/4 divided by 3/4 equals 1/3, because 3/4 of 1/3 equals 1/4. In general, the quantity A divided by B divided by the quantity C divided by D equals AD divided by BC. Let's try a problem. Problem 1. 6 students are going to share a half gallon of chocolate chip ice cream equally. Express as a fraction of a gallon how much ice cream will each student get. So the answer, 1/2 gallon divided by 6 students equals 1/2 divided by 6 equals 1/2 times 1/6 equals 1/12. Let's try another problem. There's 1/8 of a pie in the refrigerator with your name on it. The serving size is usually 1/4 of a pie. It's a small pie. How many servings of pie are there? So let's start with your intuition. You can visualize 1/8 of a pie, and you can visualize 1/4 of a pie. And you can probably see that 1/8 of a pie is half the size of 1/4 of a pie. So let's do the math. 1/8 divided by 1/4 equals 1/8 times 4 equals 1/2 of a serving. And that lines up with our intuition. Note also that 1/2 is greater than 1/8. So dividing a number by a fraction whose value is between 0 and 1 will result in a bigger number, not a smaller number. Let's try a third problem. Central Park in New York City is basically rectangular. It is about 1 1/4 square miles in area and about 1/2 mile wide. What is the length in miles? So let's look at the information that we have. We know the area, 1 1/4 square miles. That's also equal to 5/4 square miles. And we also know the width, 1/2 mile. So you know from finding the area of a rectangle that the surface area equals length times the width. In this case, our area equals 5/4. That's our area. To solve for length, 5/4 divided by 1/2 equals 2.5 miles long. You are probably a star at operating on numbers from 0 to 99, but now it is time to step up your game. We're going to tackle multi-digit number operations using the same procedures, only the size of the number adds complexity. How would you go about finding the quotient to 32 divided by 512? So we have a couple of tips. Line up the decimal points in the dividend and the quotient, and put in as many zeros to the right of the dividend's decimal point as you need to compute a quotient. So from the example, you can see we've added decimal point to the right of 32 and 4 zeros to the right of the decimal point. Above it, we have added a 0 and a decimal point, which we line up under the 32 dividend. And we have steps for you to go through when you go through the slides. So we're going to move on now to the next problem. Let's try adding two large numbers with decimals. Line up your decimal points, start adding from the right, and jot down each carry-forward number if you find it hard to remember. So here we've lined up our decimal points, and we've added the steps, and again, go to the slides to go through the steps one by one. It's too much detail to go through in the video. Moving on to the next, I'm going to try subtracting a large number from another large number, both with decimals. So the tips are: line up your decimal points, start from the right, and check your work by adding the result in the second term. They should equal the first term. So here in the example, we've lined up our decimal points. Starting from the right, you do your subtractions just like you do for whole numbers. We have our steps here, which you can look through more carefully when you go through the slides. And finally, let's look at multiplying big numbers, both with decimals. We have 3 tips. You don't need to line up your decimal points with multiplication. You do need to stagger the computation lines as noted, and you need to count the number of digits to the right of the decimal places in the 2 terms and use this number to determine where to put the decimal place in the final result. So you can see our first term, 479.35, has 2 digits to the right of the decimal point, and our second term, 28.14, also has 2 digits to the right of the decimal point. So 2 plus 2 equals 4. We put our decimal place 4 digits to the right of the final result. So 13488.9090 has the decimal point place 4 digits from the right. We have our steps here, which you can look through when you go through the slides. That ends part 1 of our number system video. Please be sure to watch part 2. Thank you.